Hi friends. So in the last video we saw more of relations and functions. Okay, I hope you have gone through that properly. Okay. Today in this video I would like to discuss more about a specific function, that is modulus function. All right. Let's see. Now in childhood we had studied this much, that if suppose the two vertical lines is nothing but the symbol for modulus, and in short form we call it as mod, isn't it? So suppose if we have mod of -7, then we were very clear that outside we should write it as 7. We should write this as 7. Yeah. And if we have mod of 7, again, comfortably we will write it as 7. So one thing was very, very clear, that the answer of the modulus, the final outcome, will never ever be negative. Will never be negative. Does it mean that it will always be positive? Of course not, because it can be 0 also. So be very careful. We have three types of values, right? Negative, 0, and positive. Cool. So now, if I have something like this, let's say mod of x is equal to 7. Now x is a variable. Output is known, that is 7. So what should be the input? Correct. Inside you can have -7 or you can have 7, isn't it? Means if I just solve this further, I should write this as x is equal to plus or -7. So this is what we call it as mod will open in two ways. Yeah, that is, let me write it again. So if mod of x is equal to 7, so it will open in two ways. Mod of x will open as it is, or it will open negatively. I'll tell you more on this. Just hold on. So x is equal to 7 or minus x is equal to 7, and solving this, we got x as -7. That is how you see x is equal to +7 or -7. Yeah, inside you can have -7 or +7. If the outside value, that is the final outcome, is positive, that is 7. So input inside you can have -7 or +7, right? Okay. So we expect to get two answers in case of modulus. Yeah. Let me write this as a proper definition in the form of a proper definition. So mod of x will open as it is, not always. Only if inside value is non-negative, that is 0 or positive. And mod of x will open as -x if x is negative. Hold on, I know some of you might be thinking, how come outside mod I am able to see -x? Minus, why? Wait, just look at this condition. So here x specifically is a negative number, and there is a minus sign outside x. So don't you feel negative of negative ultimate outcome is positive? So actually you can see that this is a mechanism behind the scenes so that the outcome shown is positive. So mod will have to negate the negative value. That is why the outcome shown will be positive. Okay. Yeah. Mod won't have to do anything if inside value is already not negative. So it will reproduce this as it is. But if inside value is negative, it will have to negate that negative value, right? Yeah, that is the function. That is the job of this modulus function, modulus machine. Okay. Let's take example also. Let me take a negative number, x is equal to -7 in the above example only. So when we say mod of x, it means mod of -7. The outcome shown is 7. Can you just go back one step in between? Can I write 7 as minus of -7? Isn't it? And x was -7, so I can resubstitute this as -x. I'm sure you are understanding now. So mod x is ultimately -x. Because x was negative, that is why -x will be positive, isn't it? Clear? Cool. So this is the proper definition of mod. which you should know properly. Okay, cool. Also, suppose let me take one more example. Suppose x minus 7 mod is equal to 8. Yeah. So mod will open in two ways. If inside value is more than or equal to 0, that is x is more than or equal to 7, right? Then mod will open as it is. As it is means just remove that sign of modulus is equal to 8, and on solving this 8 plus 7, so you'll get x as 15. Is it acceptable? Yes, it is. Now we were expecting to get x as more than or equal to 7, and we got 15. This is perfectly in sync with our assumption under which we opened the mod as it is. This is perfectly fine. Second case means or no? X minus 7 is negative. That is, we expect x to be less than 7. Under this condition, come on, if inside there is a negative term, after opening the mod, how will the mod open up? Negative of that inside value, right? Mod will open negatively. Earlier mod opened as it is, now it will open negatively. I hope you are understanding. I hope you are following this. Is equal to 8. Yeah, this is the standard process. X minus 7 multiplying both sides by minus 1. So I can do it like this, or I can open the bracket on the left side only. Both are one and the same. If you want, there is no need of this bracket. Okay. So x is equal to 7 minus 8. So ultimately x is equal to minus 1. Is it in sync with this assumption? Yes, of course. So here we got two values of x. You can always verify this. Yes, friends. If I put x as 15, 15 minus 7, 8. Mod of 8 is 8. Verified, satisfied. And if x is minus 1, put it minus 1 minus 7 minus 8. Modulus, apply mod 8, isn't it? Great. Yeah. Super. There is one more way to look at mod. Yeah. So just hold on. I'll tell you. Say this, friends. Mod of x. Actually, modulus is a Greek word. You might have wondered, right? Why it can never be negative. In functions video also I had told you. Yes. Modulus simply means distance. So distance, but there should be a reference that is of x from where? From origin. So mod of x in itself logically means that we are measuring the distance of x from origin. So that reference point over here is origin. So visualize this number line once again. If I say mod of 3, so mod of 3 means distance of 3 in place of x, there is 3 now. So distance of 3 from origin. What is distance of 3 from origin? Of course, 3 units, right? All right. So mod of 3 is 3. It will be minus mod of minus 3. Yes, you are right. Distance of minus 3 from origin. Now distance, how can distance be negative? The distance of minus 3 from origin is 3 units, isn't it? Cool. Understood? Hence mod of minus 3 is also 3. I hope it is more and more convincing now that why mod can never ever be negative. All right. So again, revising the same definition. So mod of x is as it is, that is x, if inside value is non-negative, that is 0 or positive. Technically here we should have non-negative. Okay, because 0 is not considered as positive. And mod of x is minus x if x is negative, isn't it? Because 3 was minus of minus 3. All right, clear till here? Definition both these ways. In mod opens in two ways, as it is and negatively. And secondly, the second logic, distance. Mod means distance. Okay. All right. Let's go ahead. Let's explore some properties of modulus. So if you have mod of x minus y versus mod of y minus x. If there was no mod, obviously they both are not equal. But because of the mod being there, you can check through various values and explore 5 minus 3 and 3 minus 5. If you apply mod on both of them, Yes, ultimately both will give you the final outcome as 2, isn't it? So both are same, correct? Next, mod of x into y versus mod of x into mod of y. I hope you must have explored some values in your mind. Yes, both positive, both negative, negative, positive, whatever you take, in all the cases, ultimately you will see that the final outcomes match. Okay, final outcomes match, means it is equal. Okay, let's go ahead. Mod of x plus y versus mod of x separately plus mod of y. Yes, there should be some catch here. Now, when you take both positive or both negative, you'll always find that both the sides will be equal. You can check here 8, 8, both the sides are matching, both are 8. Now, if you take a different sign values, opposite values, positive, negative, so left side is 5 minus 3, so it will reduce, that is 2, and right side, because of that mod being present separately, so mod of 3 will be added as 3, na, ultimately. So 5 plus 3, 8, so right side will be more. So combining both the cases, we can say that mod of x plus y will be either less than or equal to mod of x plus mod of y. Isn't it clear? You can take both of them as negative values also, then also equality will be there. All right. But in opposite side, right side will be bigger than the left side. One more. The way we saw mod of x plus y, of course, what can be the next possibility? Yes, mod of x minus y, you were right. So mod of x minus y versus mod of x minus mod of y. When both are of same sign, of course, equality will hold true. Yes. All right. Opposite sign. Now see, if y is negative, there is also a negative outside y. So 5 minus minus 3. So now this will become bigger, right? And here minus 3 will be subtracted as 3 ultimately, because mod of minus 3 is 3. So 5 minus 3, 2. So this side it is 2 and this side it is 8. So now left hand side is bigger than right hand side when you can take opposite values. All right. So combining both the thoughts, left hand side is either more than or equal to right hand side. So broadly, these 4 scenarios you should be comfortable with when we are doing with some simplification steps in some tricky sums. All right, comfortable till here? Okay. Now coming to inequations involving modulus. Inequations. We had already seen inequations under linear, quadratic, and higher order situations. Yeah, that time I told you we will discuss modulus separately. So here's the time. Okay. First way, let me solve it in a technical manner. All right. Now inequations. So see, first of all, I'll show you the definition method. Yeah. So mod of x more than 5. You know very well mod opens in 2 ways under 2 conditions, when inside value is non-negative and inside value is negative. Yeah. So if x is more than equal to 0, mod of x will open as it is, that is free of those symbols, those 2 vertical lines. Okay, rest all as it is. Then mod of x will open as negative x, isn't it? Because x is negative. Of course, in between we have the word or, isn't it? And let's just rewrite the second part as a standard form. Standard form means we prefer the coefficient of variable to be positive. So I'm going to get rid of this minus sign. Now, how do we get rid of this minus sign? Of course, multiplying by minus 1, isn't it? So multiply both sides of minus 1. So we'll get it as x and here minus 5. I hope you could listen to me even without saying. Correct? Inequation is there. Multiplying both sides by negative. So inequality symbol has to change, right? Okay. So summarizing this, x more than 5 or x is less than minus 5. Okay. Got it? This is with respect to the definition logic. Okay. Now comes logical way, distance logic. So mod of x means what? Distance of x from origin. So now how do we read this? Distance of x from origin is more than 5. Hold on. If you want, you can just copy this. I'll erase this. Pause the video, copy it. Okay. Thank you. Distance of x from origin should be more than 5. Okay. So this is our origin. First reach till 5. So this distance is equal to 5. So I have to go beyond this. Beyond this means to the right side of 5. Then only the distance will be more than 5, isn't it? Yes. Means for all these values wherein the x value is above 5, more than 5, the overall distance of x from origin will be more than 5. Similarly, on the left side, come on, the mirror image part, till -5, distance will be exactly 5, yes or no? But I want the distance to be more. Distance to be more means keep on going forward. That is to the left of -5. So for these values of x, distance of x from origin will be more than 5 units, correct? These values means here x is less than -5 and on that side x is more than 5, correct? This was your x less than -5 and this was your x more than 5. Of course, both of them cannot be true at the same time. So which word will be there in between? Yes, or either this or that. Understood this much? Yeah. So mod x equal to 5, you can think like that. Get the 2 points, yeah, on the number line. Then its answer will be beyond those 2 points. Beyond that, it is open towards both sides till infinity. Second example, mod of x minus 4 less than 9. Pause the video, try and solve on your own, at least through that definition logic. And then play the video to see this solution. Okay. Okay, so let's see the definition way. So mod of x minus 4, it will open in 2 ways, right? And inside value is non-negative and inside value is negative. So if x is more than or equal to 4, x minus 4 will be 0 or positive, so it will open as it is. Isn't it? Adding 4 doesn't change the inequality. So I got one condition, one range, x to be less than 13. When x minus 4 is negative, that is x is less than 4, then mod will open negatively. So minus of x minus 4 less than 9. Correct? That is how we have done it earlier. Multiply both sides by -1. You're multiplying by negative. So less than will become, yes, more than. Add 4. -9 plus 4, -5. Let's visualize this on the number line. -5 and 13. It says x less than 13 means to the left of 13 all the values. X more than -5 means to the right of -5 all the values. Can you see something common between them? Yes. So these values are common between them means here both the conditions will be satisfied at the same time, isn't it? So x will be less than 13 and now I can say and, correct? And x will be more than -5. This is how we can write now, correct? So if you see, it is in between those two values, it is inside. In more than situation, it was outside, beyond. So this is how you should solve with definition logic. Now, for at least these kind of questions, distance logic is very, very fast. Okay, I hope you have noted that, you have verified that. The definition logic, I'm erasing that. Okay. Mod of x minus 4 means what? Distance of x from 4. How I got that 4? See, earlier, if you equate this to 0, so you directly got x equal to 0, right? So reference point is origin. Now, if you equate this to 0, x minus 4 is equal to 0, because wherever you start from, that is like 0 point now. At that moment, distance is 0. As you move further, distance increases. So if x minus 4 is supposed to be 0, so x should be what? Yes, x should be 4. That is how I got my reference. So at x equal to 4, this whole thing will become 0, right? So reference point is 4. So my new origin is 4. Can I say my new origin is 4? Yes, the new origin is 4. From 4, You have to travel a distance of 9 units. Correct. You can travel on either sides. On this side, if you travel 4 plus 9, 13. So you will reach 13. But if I go beyond 13, distance will increase. But I want the distance to be less. So I should stay inside 13, to the left of 13. So all the values of x to the left of 13 will satisfy that condition. And on this side, if you travel a distance of 4 units to the left of 4, come on, from 4 to the left of 4, 9 units. So 4 minus 9. So that point will be minus 5, isn't it? If I keep going beyond, distance will increase, but I want the distance to be less. So I should be staying to the right side of minus 5. Combining both. Yes, that is what we had got. You can see the shaded portion. So this is like common to both. So x should be between minus 5 and 13 only for these values of x. That particular modulus inequality will be satisfied. Isn't it? Remember, na, you can also write this as x belongs to the interval minus 5 comma 13, and since equality is not there, so this bracket. And here, yes, x belongs to negative infinity to minus 5, this bracket, because equality is not there, union 5 to infinity, interval notation. All right, I hope you understood till here. Let's see something more about this modulus, especially from the graph point of view, because some tricky questions will be solved through graph conveniently well, right? When I say visualize, you should visualize the graph. Yeah. So this function is nothing but the modulus function, isn't it? Which, because it involves that modulus. Yes. The graph, if you remember, we had discussed in function, it will be like a V-shaped, correct? Something like this. Why that vertex is not an origin, you'll understand. Stay tuned. See, when we draw the line y equal to x, remember identity function, input is same as output, lazy function. So it was nothing but a straight line passing through origin, inclined at an angle of 45 degree with positive x-axis. Isn't it? So this angle is 45 degree. Now, if we were to draw y equal to mod x, we had drawn that earlier. Let's understand from this logic also. You know that y cannot be negative. So this is the negative zone of y here. Every point has y coordinate negative, isn't it? So this will be like reflected upwards. The value will remain same. So for example, whatever this height is, same height will be there up. Every point will be shifted up in the second quadrant. Correct? So finally, see, first quadrant line will stay as it is, but whatever portion of the graph was there in the third quadrant, that will reflect up about x-axis. So that is how we used to see this V. It is perfectly inclined at 45 degree with respect to x-axis from both sides, perfectly in between. Okay. What about this 2 times x and then mod? If you draw similarly by taking points, you will see that V is getting steeper. It is moving closer to the y-axis. What about this x upon 3? It will become flatter. That is, it will move more towards x-axis. These thoughts should be clear, friends. Accordingly, we can take good decisions while solving those tricky questions. Okay. So can I conclude coefficient of x decides the steepness? Yeah, if it is more than 1, the graph will be moving towards y-axis, so it will be steeper. And if it is less than 1, it will be moving towards x-axis. That is, it will be flatter. Yeah, in a way, it is also called as slope. So coefficient of x gives us the slope of the lines. Let's see more in detail. What if we have something like this? Some constant apart from x term, that is ax plus b. Now the vertex, in earlier examples, if you see, the vertex was like origin only. Because when x was 0, y was 0. Correct, na? Wherever in the mod, if you put x as 0, you got y as 0. X as 0, y as 0. There's no extra term inside it. Now we have, so if I want to make it 0, so ax plus b is equal to 0. That is how we should find the vertex. So x is equal to minus b over a. After solving this, right? I have skipped in between step. Ax is equal to minus b. Okay. So x is minus b by a means at this value of x, this whole thing will be 0. Means coordinates of the vertex will be, I'm denoting the vertex as b, minus b by a, comma 0, isn't it? Yeah. For example, take this 2x minus 6, so equate this to 0. So 2x minus 6 is equal to 0. So x is 6 by 2, that is 3. So when x is 3, y will be 0. So vertex now will be 3 comma 0, means that v will be at 3, but a steeper v. Why? Coefficient of x is 2, not 1. Okay, see this, isn't it? Understood this? All right. What if we draw this? Same thing. Equate this to 0. X by 3 plus 2 is equal to 0. So x by 3 is equal to minus 2. So x is equal to minus 6. So when x is minus 6, this whole thing will become 0. That is when x is minus 6, y is 0. So minus 6 comma 0 will be the new vertex. What will be the shape of v? Yes, coefficient is 1 by 3. So it will be flatter v, more towards x-axis. Isn't it? See, something like this. Okay. All right. Let's go ahead. Now you have constant outside the mod. Earlier the constant was inside the mod. Same thing, you'll understand that the graph will shift up or down by that value c. Earlier it was shifting on x-axis, now it will shift on y-axis. Okay, let's see. Let's see through example. Y equal to 2x minus 6. Now the lowest value of mod is 0, right? Modulus is never negative. Hello. So mod x is always more than or equal to 0. Means mod x, if you see mod x is negative, it is impossible. Means if you see some question like solve this, straight away you should say no solution. There is no value of x such that if you substitute that and we'll get the answer as minus 7. Impossible. So if I equate this to 0, 2x equal to 0, this means x equal to 0. Now when x is 0, this is 0, but minus 6 will remain. Now, so at that time, y is minus 6, isn't it? Understand input, output. Now you understand the functions, right? So input, output. So when input is 0, output is minus 6. So vertex is 0, comma minus 6. First thing. So 0, comma minus 6 will be the vertex. This is the minus 6 point. And steeper v, because coefficient of x is 2. Yeah. Check this. This is mod of 2x minus 6. Steeper v, vertex is at 0, minus 0, comma minus 6. Sorry, it's not origin now. In short, that earlier v, which was here, yeah, at origin got shifted downwards by 6 units because of this minus 6. That way also you can look at the same thing. Let's try and draw this. Find the vertex. This will be 0, equal to 0 karenge, so x will be 0. And when x is 0, y will be 2, isn't it? So 0, comma 2 will be the vertex. Coefficient of x is 1 by 3. So flatter v at 0, comma 2. Understood? These small variations. Great. It will be helpful in understanding maxima, minima. All right. Chalo. So finally, you know that this will move to the left or right by this. Yeah. And the vertical movement will be decided by that c. For example, mod of 2x plus 4 minus 5. Chalo, let's do it quickly. So 2x plus 4 equal to 0. Lowest value is 0 for any mod. So x is equal to minus 4 by 2. So x is equal to minus 2. So when x is minus 2, this whole thing will become 0. So what will remain is minus 5. Because at that time, y will be minus 5 or f of minus 2 will be minus 5. Remember f of x? Yes. So minus 2 comma minus 5 will be the vertex. Steeper v, I hope you have understood because of the coefficient of x. Yes. Yeah. This is at minus 5 point. So this will be the vertex. Minus 2 comma minus 5. All right. This one similarly, come on, you tell me. Correct. 4 comma 1, isn't it? So when this is 4, x is 4, and when x is 4, y will be 1. So 4 comma 1 will be the new vertex. Yes. And a normal v, inclined at 45-degree wala v. Okay. All right. Now whenever the v is upward facing, maximum will be not defined, right? But minimum point will be defined, and that point will be your that vertex point, that point where the vertex is. And downward facing mod, downward facing v, in short a, will have a unique maximum point. Lowest value will not be defined, right? Beyond imagination. Yes. correct? So for this type of V, this is the vertex. So at this value of X, we have the Y as C. So sorry, ignore this. X is minus B by A and Y is C. So at this value of X, this will be the lowest value. At means value of X. And what is that value? Value of the function means value of the Y. Okay. So when we say where will that point be, means location we are trying to understand. So X, the value of X will help us locate that point. And at that X, what is the value of the function? So input में X में value जाएगा, output में Y का answer आता है. So the value of Y will give us the value of the function, isn't it? So if we are asked to find what is minimum or maximum, at X equal to minus B by A, it will happen and that value will be C. Yeah. All right. Let's see through these examples. So when X is, come on. Yes, 2X minus 8 equal to 0. So X is 4, right? At X equal to 4, this will assume its lowest value, that is 0. So Y will be minus 3. So 4 comma minus 3 and a steeper V. So at X equal to 4, the minimum value will happen. And that minimum value is, yes, minus 3. Okay. All right. Now, what about this mod? I hope you know, if minus n is there outside the mod, the V will flip, right? Yes. So when you equate this to 0, so X is equal to minus 2 aega. When X is equal to minus 2, this will become 0. So Y equal to 5 will remain. That point is minus 2 comma 5. But ulta V means kind of A. So add minus 2 comma 5. So vertex is minus 2 comma 5. Yes. So at X equal to minus 2, the highest value for this function is 5. Yes, it will happen at X equal to minus 2. Understood? Rest all the points are below that point. So Y is continuously reducing. The highest Y was this only. That is 5. And where did this happen? At X equal to minus 2. Cool. And why this kind of V? Ulta V matlab the coefficient of mod was negative. Yes. Okay. This is the final summary now. Whatever we studied till now in this case. So A, that is the coefficient of X, indicates the steepness. Remember? Clear? If the sign outside the modulus is positive, it is upward V. The curve faces upwards, while if it is negative, the curve faces downwards. Something similar to our parabola in quadratic we had studied, right? Yes. Higher the value of A, steeper the lines. Lower the value, flatter. The maximum or minimum will occur at when you equate this to 0. That is how you get this. And the value of Y at that point is C, right? Clear? Okay. So just keep these things in mind. So I hope you understood. Thank you so much. Stay tuned for the next updates, next videos. Take care.